This video solves problem command 103. At this moment, you should pause the video and look at the statement of the problem in your computer, or stop the video and look at the statement here. Okay, the problem goes about three economic quantities: savings, investment, and rent, which depend on time as the independent variable. And we have certain assumptions. Here, first of all, the savings are 0.45. The rent here, we have investment is 0.15, the change of the rent. So this is a differential equation. This is the same as I equals 0.15 y prime. And finally, the assumption that savings equals investment. And we are asked to find an expression for y. So as saving equals investment, from here we replace savings here, 0.45 y equals to investment from here, 0.15 dy over dt. Let's move the 0.15 to the other side, and 0.45, let me change the color so you can see here, that's green. If we move here, we have 0.45 divided by 0.15, that's 3. So going back to blue, we have from here 3y equals dy over dt. Okay, let me rewrite it this. Dy over dt equals to 3y. This is a separation of variables type of equation, and to see, so we have dy over dt equals 3y. We move the dt to the other side, dy equals 3y dt, and now move y dividing here, 1 over y dy equals to 3 dt. And now we do the method, which is integrate both sides. Okay, so new page here, back to blue, and the equation is 1 over y dy equals 3 dt, and then integrate this and this, so we get the log of the absolute value of y equals 3t plus c. Two things here to remark. First of all, y is rent, y is money, so y is assumed that is to be a positive amount, so no need to take absolute value, we can take the log of y. And the second thing, which is explained in a separate video, in a different video, we have only put plus c, one constant of integration, but that's always the case. Watch the other video. Okay, so we're here, back to log of y with our absolute value equals to 3t plus c, and we want an expression for y, so we exponentiate both sides. And what do we have? Y e to the log of y. Let me erase this a little bit, but we have here e to the log of y is equals to e to the 3t plus c. Okay, as we know, we have seen many times in class, exponentiation and log are inverse functions. This means that if you do one and the other, it's like not doing anything. So from here, we have e to the log of y is simply y. On the other hand, this, by the properties of the log, which I'll write here in green, of the exponential, we have e to the a plus b is e to the a times e to the b. So in this case in particular, e to the 3t plus c is equals to e to the 3t e to the c. Now c is a constant, right? So if c is a number, a constant, a number, then e to the c is a number also, right? There's no difference. I mean, the name will be, the value will be different, but it's just a number, so we can call it k, and write this, it looks better, as k times e to the 3t. So recapping, we have this and this here, and the solution for our equation, our problem is the rent is equals to k e to the 3t. Okay, let me just check it. You don't want to do this, it's okay. But let me check that we have a correct solution. S was 0.45y, which means 0.45 times k e to the 3t. And I was 0.15 y prime, which is 0.15. And now the derivative of y is k, here is y. 3 goes down, e to the 3t times 3. And that's equals 3 times 0.15 is 0.45 k e to the 3t. And as you can see from these two formulas, we have, sorry for this, let me erase this we, which doesn't look like we. And then we have that s equals to I, and that's correct solution.